Great stuff. So then we have the first speaker. It's a Sebastian Daschner. Sebastian is a lead developer advocate for IBM. So his role to share knowledge and educate developers about Java, enterprise software, and IT in general. He believes that teaching others not only greatly improves their situation, but also educates himself. Sebastian's goal is to focus on how concept works and why specific solutions are needed, and only how they are implemented. And I think the topic is about Java for the clouds with Quarkus. You have probably heard about supersonic, superatomic Java with Quarkus and new runtime for cloud native applications. So in this session, we will see why Java developers should care about Quarkus, what makes it special for modern container-based workloads, and what it has to offer with regards to developer experience. So, and also it should be live coding keynote. Great. Thank you. Welcome, Sebastian. Then.
Let's
Hi.
hope so. Yes. Thanks a lot. And hi for thanks a lot for this introduction. And yes, let's hope that we have some live coding fun because quite frankly, I'm not a big fan of slides because I think it's just more fun to watch somebody coding, right? And I want to show why Quarkus might be an interesting technology for Java developers, especially for the clouds. Okay, so I hope you should be able to. At first, I was just showing the website. This one, Quarkus, you don't see much, supersonic subatomic Java. And now you will see, well, some code. So that's the Maven code. You've probably seen the Maven POM XML. And this coffee shop project I was talking about, that's this one. And here, well, we have a few dependencies, such a bill of materials, and well, just some versioning. Java 14, that's what I'm using here, Quarkus in a specific version, and that's basically it. And well, why it is quite interesting to begin with, so I could walk you through some APIs and some usage, but well, I think it's especially interesting for two reasons. The first reason I want to show you is the developer experience. So it's really fun to code with Quarkus. Why? Because the creators really took this developer experience into account to have a short turnaround time while developing. Okay, what does this mean? Let's go into our command line and we can try to build our project. So usually we would do something like Maven clean package or Maven package, or so a similar goal for Maven. But in this case, what I want to run is Quarkus :dev for this so-called development mode. And what that does, first of all, it starts up a Quarkus plugin. This is typically included in the Quarkus projects. So if you are starting out, the website shows you how to do this, but of course you also will get access to all this code. Then you include this plugin here, which will, well, just activate this so-called development mode, which is quite interesting because it allows us actually to run this application locally in a way where we still have the connection to the source code. So if I, for example, go and say, well, now this is apparently running under localhost 8080. So if I go to localhost 8080, then I should see something. And well, yes, I actually already built some HTML site for that. Let's go a little bit simpler. Let's check /health for some health check. And it says, well, yeah, there's something running here. Okay, so that was easy. And but I didn't change anything yet. So that is basically just I started my application in this development mode. And now what I can do, and that's kind of the cool thing, I can actually go and say, well, for example, I want to change something in the code while the thing keeps running. So this is this developer experience. So for example, if I, and my program is still running, if I write a new class, something like a proper health check, what I'm doing here, I'm using some Java Enterprise known APIs. So Quarkus supports, well, all kinds of APIs, Java EE, Jakarta EE, microprofile, even some Spring annotations and some Spring types. And here what I'm going to use is a so-called readiness probe from microprofile. So microprofile health allows me to quickly write some health checks, and I can say, well, please just implement some health check here. and implement a very basic response where you just say, well, everything is up and running, and say health check response, something like coffee shop is up, and that's it. Okay, now if I run this again, then very quickly it will restart my application and says, okay, now I see a different response. Okay, interesting, this check is now up and running. Okay, cool. And you saw this was very quickly, right? Usually I would have to like stop this process, rebuild again, restart the process, or if I'm using Docker containers, rebuild the Docker container, and it always adds some, turnaround time of at least 10 seconds. But in this case, I can just quickly call that, which is really, really cool and really convenient. And while if I have some other stuff as well, for example, if I say I want to build not only this hello world response, but something like builder with named and then add some data. So for example, I can add some data like, hello world. So this is not too interesting. This is just like some extra metadata for my health check. But the reason why I'm showing you this is to show you that I can actually add something in the code. And why is it down now? Probably I forgot to call up. Yes. Now it's up again, and you see how quickly we see the response time. And this is probably one of the most important things when we program in general, that we need to keep these response times short. Why? Because we are human beings, we are humans, we just get distracted, right? You know what happens if you use this old legacy technology, your old, application server that takes half an hour or maybe, 3 minutes to start, even 3 minutes or 1 minute, that just takes too long. Because 1 minute and I'm like, yeah, let's check social media, let's check Slack, let's check email, Twitter, and then I'm distracted. So I need to stay in this flow experience of saying, okay, I can actually immediately see what's going on. I can see whether the thing that I just used worked. Okay, what else we can implement or use here? There are all kinds of APIs that I could show you. So if you're a Java developer, you might be familiar with some of these enterprise APIs already. I just, for the sake of the example, want to include some other string actually that is provided by a config. So this is microprofile config, the add config property annotation. And this can be used here as well. So if I say instead of hello, let's call this version, and the version will be a version of my application, whatever that means. And then I can say, okay, the version is now 123. Okay, you might ask, where does that come from? Well, this is how Quarkus is configured per default or can be configured. This is the application properties that resides on the resources, which is an approach that I really like because it's very straightforward, right? So compared with some more legacy application servers, this is really easy to configure. Just put in the properties, whatever you like. We have some Quarkus properties there as well. And the cool thing is, if I change something here, this development mode actually keeps track of all of these things, of all of these resources, also HTML files, stuff like that. I can actually change that and very quickly restart my application and see the changes being reflected. So this is really, really helpful, and that's really powerful, right? Because it enables us to do whatever we like and then just see the response immediately being there, right? And that's very cool. So let's actually see what the application is doing, right? So I was telling you about coffee and we only saw some hello world responses. So what I want to show, and that's now a little bit more into the Java enterprise APIs. So if you're familiar with some, enterprise Java stuff, so even if you're a Spring developer, this might look probably very familiar. It's very similar like a Spring REST controller in that case. Here, this is called JAX-REST. That's just an API to write RESTful HTTP resources. And we have some path here, orders, which corresponds to something /orders, where, well, I can manage some coffee orders. Let's check this out, orders, and what it is, well, just an empty JSON array. So in this case, I called get to give me some orders, to get some orders. Okay, cool. In this case, they are just returned, but I can also create an order. I can order some coffee. Interesting, in this case, what I need to do is I need to post some JSON to this HTTP resource. For example, some coffee order that has some, what is a coffee order? It has some type, some status and things like that. So I can include some type. Let's say I would like to have an espresso as a coffee order. Okay, cool. Or maybe another one. And now we have 2 espresso in the system. Okay, well, that's easy. Hello world, right? But that is basically what the application here does. And I can see this output by just using this API. And I could also change something here. So for example, if I go and let's see what's the current status of the code, I can order some coffee, and let's go back, coffee shop, order coffee. What it does, this is basically my business use case class, the coffee shop class. That's just, again, CDI. If you ever use this API, this is very familiar to a lot of developers. Add application scoped makes this thing an application scoped bean. I can add, inject some other dependencies, some other beans. So this is just reusing the APIs that are already out there, which is what I really like. And I think it makes sense because Quarkus is a fairly new technology. It came out roughly 2 years ago, and it still did not invent or reinvent a lot of stuff that's already there, right? Because what is the benefit of writing yet another HTTP Java API? We have so many already, like for RESTful web services, also declarative style, right? There is Spring, there's JAX-RS, there are even a few other ones. Why invent another one? They're good enough. They do what they're supposed to. So why not just use them and implement them? And this is what Quarkus does, and I really like this approach. So what the coffee shop here does, it retrieves some orders. They are basically stored, well, in memory in a hash map. And if I want to order some coffee, I create the coffee here. So for example, we could follow a specific link as well. We have some link where we see the order. And now we see, well, the price doesn't really work. That's too cheap, right? Like it's for free. That's not good. So let's change this. Let's include some price. But the price should be, let's code a little bit of Java code here. The price should be dependent of, well, the drink, of course. So we have the different types. We have an espresso, we have a latte, and there are, different prices. So let's include this as well. Let's have something like a, price calculator. And again, I still run this development mode, right? Like, and you can do whatever you like. It will just like try to recompile your application, recompile. If it doesn't work, it tries again until it works, which is really nice because I don't have to think about it. I basically say, well, just write a new bean that's called price calculator. This, of course, doesn't exist yet. So we create class somewhere in, let's say I usually use this boundary control entity pattern structure. This is an application scoped bean as well. This should be injected and say, okay, price calculator, please calculate the price of a specific order and then set the price here. And the price is a double. Please don't do that in real life. Don't use floating point calculation for currencies. But in example, that's fine. And say, okay, calculate the price. So what is the price here? Well, I don't know. It depends on the type, right? So for something like espresso, pour over, latte, they're different. So as you've seen, I used this config API before. I could now go and say, well, inject these 3 different configs, but that's too complicated. I can even say, well, I want to do this in a programmatic way, and this works. So I could say something like get configured price for the order type, which now should be a method that I create here. And the method should return, there is a, it's called config provider by microprofile config. And then I can say get the config, which then enables me to programmatically access the whole stuff. So I can say, well, the property should be, okay, let's start with the easy thing. The type, that's easy, that's a double. And the property should be coffee.prices.whatever the type, right? So I can say type name to lowercase, something like this, right? Let's outsource this to a property key, coffee prices dot something, okay, and then now return this. Interesting. Who thinks this will work? Well, I don't know. Let's try it out. Good thing is, my development mode is still running, I can actually now re-invoke an endpoint. If it would not work, if it would give me an exception and say, well, compilation failed, please fix this first, but it seemed to work. Now I quickly restarted the application again, so the list of orders is empty. That's just for test purposes anyway. And I can say, well, please create a new espresso order and a new latte order. Okay. And now I have 2 orders in the system, so let's check them out. The first one has a price of 3, whatever it is, dollars, euro, wherever you think that's cheap or not. But let's check here. Okay, latte, €3, sounds about right. Let's check the other one. That's curl, check the espresso, and that should be okay, 1.5. Still expensive, I think, but it's configured correctly. So now we see we can change the live code. We can access some configuration here programmatically. That's thanks to microprofile config. But just to show you what is possible here using this development mode experience. And that is really, really helpful again. So what is also, I think, even more impressive that this, let me stop this again, it not only works with a single local process, right? So a single application. When I'm starting up my coffee shop, that's just one application that's, like it's kind of boring because hello world and I can access it. It also works in a more complex setup. And if you're interested in that, I even recorded some videos on that. So you can check that out if you like, because you can run your application actually in a container with your Quarkus app with this kind of development mode, and then debug and have this development mode inside your container. So why would you do this? Well, it might be helpful. Let me just start this up while I'm talking. System test for another project. It might be helpful for the following reason. If you have a more complex setup locally, for example, you need multiple containers for your database, and you have an external system as well, and you need to use the actual containerized application, the packets application, because of some network configuration or because of some configuration in general. So you want to run the same thing like later on. And this is really interesting then, that I have the same opportunity to have this development mode in a remote fashion. This is then called remote dev mode. So this works as well. If you're interested in that, you can check out some this video or some other content that I've created. But just to quickly show you this, I have another example. It's also called Coffee Shop, but this is a little bit more, you get the source code for that as well. That's a little bit more sophisticated. Why? Because it also uses a database and it also uses an external system, which is why I just started up 3 containers and not just one. One is actually a coffee shop. This is my application. One is a database, a Postgres, and one is usually an external system. In my case, it's actually a WireMock. Why? Because then I can use a system test and control the whole system as like, a mocked HTTP thing that responds like I want to. And then what I can do, I can actually run, and this is now really helpful. For example, I have a running application like the one, very similar to the one I just showed you, just a little bit more sophisticated. And now I can say, well, please run a test, connect to the application that is already running. You can even connect to this WireMock and then just control some stuff in my test scenarios, which works really well. So I can, run this test and see, okay, that is now green, and hopefully it created even some orders. Now it runs under a different port because I have multiple ports of that, and so on and so forth. So this also has a status that then will be updated. But this is not even what I want to show you. What I want to show you is that I now have an application that runs inside of a Docker container, and this is also a Quarkus application, but I run it in a special mode where I can even still have this development mode into the container. So if I go and take the source code of the other application, let's change something that is very straightforward. For example, I have some hello world response, local host, and then it just says, well, hypermedia, go and check out the coffee types, go and check out the coffee orders, create them, and so on and so forth. And if I want to change this response, there I have a class that creates all of this response. Just, it's very similar to hello world. Then I can do so, and I can very quickly even verify this in this more complex system test setup. So now this takes 1-2 seconds more to restart because it's actually doing more, but here's the response. I still have the opportunity to verify all of that, even in a more complex setup. And that's really interesting because then you always get a fast response, right? Because if I change something in my production code, well, you saw it, that's very fast. If I run my test, that's also very fast. It just connects to a running system. If I change my test, well, I can change it right away. So I really don't have to wait for almost anything once my application is up and running. So I started once in the beginning of my development session, and then I can have fast feedback always. That's really helpful here. Okay, so that's that. I wanted to show you this more sophisticated approach, which is why I will go back to this application, but now we can stop it again. We don't need the other sophisticated, where is it? Here is it. Here you see, by the way, the output of this remote dev mode. So it connects to this client here and sends the update, and then it restarts it. So this is, I think that's really cool. That's really sophisticated technology, and just that this works is really nice for us developers. Okay, so what else? Since this talk is called Java for the Clouds, in case you haven't seen this nice ASCII arts title before, I now want to show you a few more things that's specifically related to run Quarkus in the clouds, because for now there was only, well, locally, at least I was using some container. So you see Quarkus also works well with containers, but the actual reason why Quarkus is so, hot and supersonic and subatomic is actually the reason that it does a lot of interesting build time optimizations. What does that mean? If you go on the website, scroll down, you see some performance and the comparisons and some stuff about containers. It will tell you, well, how fast it is compared to a traditional cloud native stack. I think that's a Spring Boot example. And how faster a Quarkus is just in a JVM mode, and then also with this native. So what does it mean? You probably have heard about this before, and let me walk you through that. The biggest advantage what Quarkus does is this build time optimization. Let me just clean everything and build it again. What you see, if you just, now it's not the development mode, now it's a typical build that produces an executable jar. You have something like a, jar, and then this Quarkus Maven plugin that does a build. So what it does some augmentation. It basically scans your application and tries to optimize it. If you're familiar with the enterprise Java world, this is how application servers or any runtimes, also Spring, always worked. That you start your application and then they start searching. They start scanning. Which classes do you have? Which annotations do they have? Oh, this is a Spring component. This is a Spring service. This is a CDI bean. This is a JAX REST controller. And then building up all that stuff together to your application. Quarkus does that differently. Quarkus does this at build time. You see this is fairly quickly. Your build is not super fast, but at least 8 seconds. It could be faster. I mean, I advocate for builds like less than 5 seconds, but it is good enough for your Maven builds. And it will package your application in a really super optimized way. And first of all, this is no magic. This has nothing to do with anything native or anything like that. It is just optimizing your application so that once you start it up, there is no overhead. It literally has only the code that it needs to serve your application. So it's highly optimized. All the inversion of control is being taken care of already. If we look at the target directory, this means that we have, some runner that we can execute. So this, you see, this is actually kind of small with the kilobyte sizes. Runner is the one that we would start. So we could say, for example, java-jar target and coffee shop runner, and then it runs our Quarkus application. And here you see it starts up very quickly. Like this is probably my setup now with the streaming here, even slower than usual, but it would start up in, usually less than a second, which compared to traditional stack is insane. That's much, much faster. And that's just the Java optimization. Now you can take that and put it into container already, and this makes a lot of sense for a few reasons. First of all, container first, you see there's a lot of resource improvement of the resource consumption. That makes sense. Why? Because I throw a lot of stuff away. At build time, you really try to optimize as much as you can. You take away all the inversion of control, all this indirection, all this reflection and scanning. At runtime, we only have direct code, like as if you would write direct invocations from scratch. And you see this is already a huge improvement in memory consumption and in first boot time, right? You see like, usually less than a second or something. And this is really fast. This also makes a lot of sense to put that into a container, but I will talk about containers in a second. The other thing that's interesting is that because of that build time optimization, almost like a side effect, quote unquote, you can now compile it down to a native executable using GraalVM or some other optimizers or whatever the official name is. So GraalVM allows you, that's one example, that it allows you to compile your Java application down to a natively executable. But you have to add an asterisk to that. It's not that easy. If you would use your legacy application server and try to build it to native with Graal, that would not work. Why? Because, well, it's a little bit special how Graal works in terms of reflection and in terms of other features that it supports, all the features that we typically use in traditional enterprise technologies. And for that reason, Quarkus needs to do all of the build time optimization to even allow it to be compiled down to native code. But once that is the case, and this is why Quarkus does all of that magic at build time, then we can or could go native and compile it even further down, and then you literally have a native executable image. So that's a Linux or whatever architecture you use, that's the actual executable stuff. You're not running Java dash something. No, you run the actual application. That's a natively compiled thing, which has some pros and cons. I will talk about them now when we cover containers, because of course this is just a Java process, which I'm typically running is a container. So we package this typically into a Docker container. You have many ways to do that. And I could just go and say, well, do something like a Docker file, and then let's go for this example. And then, very straightforward, package everything up. I use my own Docker file or an own distribution of Java. I use typically OpenJ9, in this case Java 14 from Adopt OpenJDK. So that's just the Java I'm typically using, and then just add my application, and that's it. And then run something like java-jar, what you just saw, and run the application here. Okay, so that's quite straightforward. The reason why I actually advocate for this is for a few reasons. So in other words, I'm actually I do a few real-world projects with Quarkus, and I usually use that in a JVM mode. So now you might say, oh, that's crazy. Why not native? Because, that's the whole point. Well, not necessarily. Quarkus makes a lot of sense to run it in just the JVM mode. Why? Because it's actually faster to build. Because in order to build it down to native, you have to, that's another build to build it down to native, which I even won't show you in this session. It takes a few minutes and a lot of memory consumption, so it takes a long time. And this is not something that you always want to do. Why? Because it takes too long. You can do this as part of your deployment pipeline, like later on as a step. But I typically don't do it. Why? Because for most of the use cases and applications, the JVM mode is just good enough. The resource consumption is already so much better, and the response time is very fast. I will show you in a few seconds. We have a Kubernetes demo. I will show you the example how fast it starts up on the cloud, and then everything else is an optimization that you usually don't need. If you need to scale down to 0 and do these things like serverless and stuff, which is also not, it's more like a side or corner case, I would say. Then it might make sense to compile it down further to make the users wait less. But usually redeploying something in a zero downtime approach, taking 1 second is not a problem at all. And yes, for this reason, I typically use the JVM approach. For another reason as well, why I now can have a layered Docker image. What does this mean? This is always the case when you use some thin deployment artifacts, like we typically had in enterprise software, as opposed to fat jars. So this is also a jar, yes, I know, but it's a thin jar or slim jar, or there are multiple names for it, which only contains the classes that we actually use. So if I would look into that, coffeeshop.jar, this is my actual application one, that only contains the classes that I wrote, you remember? And everything else, including the Quarkus runtime, is included in lib. So that's just a library with all kinds of stuff. Why does this make sense? Well, because of the reason how Docker images work. So every Docker command in this file here will correspond to an image layer of your resulting Docker image. And if I build something there, it actually will get cached and optimized if I rebuild and change something that only, has been changed. So if I go and say, well, do a Docker build here, for example, to my coffee shop, and then just build it, it will be very fast. Why? Because only this step was executed and all the next steps. Everything before wasn't actually done. It just said using cache. Okay. If I do it now, nothing changed. So everything is using cache, done. Okay. It saves some time. You might say, well, that's nice. It saves you even more time if you do a transmission. If I say Docker push, well, this doesn't work. I need to build it with my own name, Sebastian Daschner coffee shop. Let's call it temp. And now I just retagged it. If I now do a Docker push to the official Docker registry, what it does, well, it only pushes a few kilobyte and done. And that's it. It doesn't push all the megabyte of the image sizes and all that stuff, which I'm usually not caring a lot how big the actual image is, the total image. I care a lot how big the diff is, because that is the stuff that changes all the time. I usually don't change, the Java version or the dependencies every second build. That happens every few weeks or something, but I change the artifact every single time. And this makes much more sense because here you see the artifacts are tiny, a few kilobyte. This makes much more sense than packaging everything up into a few megabytes and always pushing all of the megabytes. And the same actually happens if you have a native executable. Why? Because it's a single executable, it's a single file, and then you have to push everything. And that is also just an optimization that makes it faster. And because of all these reasons, I typically use the JVM mode with Quarkus. And I think it makes sense for most of the projects, actually. If you're interested in the native mode, we have another session later today in the Scrawl, about Graal by my friend Alek Shelaev, who works for Oracle. So then you can go and visit his session about how all this Graal stuff works. And I think it's a very interesting and very cool technology, just for the fact, that we can run something like enterprise Java in a native mode. I think that's just, wow. That's just really cool and interesting for all kinds of stuff, also command line applications. And just the fact that this works is very nice. By the way, I have some other resources here where I have some comparison about against OpenJ9 versus OpenJDK, which is why I use OpenJ9, which also saves you some resources versus some other JVM, but that's all on the JVM mode. So if you're interested in that, I recorded a video, and my colleague Niklas has some other comparison where I think this is quite interesting. It's kind of like in the middle, even between the OpenJDK, so it has less resource consumption and so on and so forth, and some examples how to get started with that. I think that's cool. Okay, now finally, again, Java for the clouds. Let's go into the cloud and let's deploy this container to a Kubernetes environment. Why Kubernetes? Well, because it's somewhat the de facto, or not somewhat, it's definitely the de facto containerized solution or container orchestration solution for platforms for the cloud, either in a version where you have a plain Kubernetes solution or something like OpenShift that is based on Kubernetes. So where I typically get my Kubernetes clusters from is a managed cloud environment. Why? Well, because it's easier than to manage your stuff yourself or your clusters yourself. So I have a cluster that is actually running in the cloud somewhere in Frankfurt. I use the IBM Cloud. It has the IBM Cloud for Kubernetes Service, so IKS. And that's what I'm using here. And you probably know this kube control command. So I can have something like Kube control, let's see what's running on my cluster. And well, there's nothing running. It's basically empty. So I just deployed this cluster, I think earlier today, and we can now deploy something with my Quarkus application. Okay, let's do this. What I have now, if you're not that familiar with Quarkus, don't worry. There are a lot of good examples or introductions out there. I basically have to edit my YAML files or provide these YAML files to deploy it, or at least this is what I'm typically doing. So Quarkus also supports a lot of stuff beyond that, which I think is very interesting. So for example, Quarkus has a dependency where it will actually write or manage your Kubernetes resources for you, where you say, oh, it's just a default, application, HTTP, nothing fancy, and it will certainly work for my example. And then you can just add this without even writing a single line of YAML. And the same is true for the Docker file. So typically, the recommendation is, oh, don't even write your own Docker file, let this Quarkus manage for you. But for a few reasons, I like to do these things or manage these things myself. And what I like about how Quarkus is being built is that it's somewhat opinionated, but not too opinionated. So you can always fall back to do these things yourself. And once you get familiar with Quarkus, also with the APIs, it provides a few own APIs beyond the standard ones to fill the gaps, sort of. If you see that, you will notice that it never forces you to do something in a certain way. It provides a lot of shortcuts and syntactical sugar, but it's not the only way to do that. So like, creating Docker images, there's not one way. I can write a Docker file, add my jar, and that's it. That works. That's great. I can, write my own YAML and then deploy that Docker file, that Docker image. And this also works. So, there's some opinionated stuff, but you don't have to follow it, which I think is a perfect, balance, because for some reason, if I want to do it myself, that also works. Now, this is a Kubernetes service and a deployment where I just will, deploy this image. I can access, for example, this health check resource. So, all of the typical stuff with, for example, health checking works. I can, in my application, inject some configuration by environment variables. This is very helpful. And, the typical, what you would expect nowadays in order to nicely integrate into the cloud, that works in this whole Quarkus technology, which is just very nice. All right, enough talking. Let's finally deploy this. Kube control apply, and it creates a bunch of things. I actually have an Istio cluster, so if you know what that is, then fun fact. And wow, you saw it's already actually running. So it's running up and running and ready, and you see how fast that is. So I now have a running application in my cluster. I can go and use that, of course. So I can say curl. Now it's not localhost, so basically my secret IP address from my cluster. So that's the public IP address, and say something like, well, check out the orders, which are of course empty, or check out the health check here, and says, okay, it's up and running. Great. Now let's order some coffee. So that's the whole point, right? To finally get some coffee. Espresso, there we go. And another one. And now see whether that's in the system. And yes, that works. So we now very quickly have a running example of Quarkus in the clouds, which is, well, an application that runs there. It starts up very quickly, which is really nice. Also locally, which is what you saw. And it works really well in a containerized environment because of multiple reasons, that it just makes it very, very efficient or very convenient for us developers to containerize these applications. And yeah, this is what I wanted to show you with that regard. So that's about Java for the clouds with Quarkus. We now deployed this to a Kubernetes cluster. You can of course do many more things with that. So you could even go and run this remote dev mode inside a Kubernetes cluster for a test environment, for example. Sometimes that might even make sense, but you just you see how convenient that is to take it from there. One more thing that it just comes to my mind that I forgot to show you before, but since the technology starts up that quickly, that's not a problem at all. Quarkus dev, I just start my application, and before I already mentioned debug. So what it actually does, if you start up this development mode, it also per default already starts up a debug port. So I could go, and this is really helpful not only for my manual tests, but also for some system tests. If I really don't know what's going on, I could go into my resource, for example, like the orders resource, and say, well, when creating a coffee, there's something weird happening. So please, I said, please, my IDE needs to wake up. Please set a, where is it? Breakpoint. There we go. Please set a breakpoint here, and then go and run a debug mode into a localhost debug. Why? Because it opens up this port 5005. And now if I go and say, well, localhost 8080, I don't know, health. Okay, we'll have the health check, or orders. Okay, or orders create. Please create a coffee order. And now this is where, for example, I have a bug. Presso, not only have a bug, but also I cannot type. And now you see this actually captures my IDE into this breakpoint, and I could say, okay, you know what, stored coffee order, what is that? So just step in or step over. Oh, too late. And I could, for example, see, okay, what is the parameter here? How does my order look like? Type, it's probably too small for you to read. Type espresso, and so on and so forth. And I could go and, step through all of these things. So that's really convenient in order to check out what's going on here. And that is being started per default. So now I can stop this process again, and then it just continues. So this is really helpful, and it also works in this remote development mode, which I was showing in the video that I was teasing. And that helps a lot because that's just active per default. If my system test is having some weird results, I can just see what's going on there. So just as some takeaways, I think Quarkus is somewhat the equivalent of a modern cloud-native Java because of a lot of optimizations and just that it has been built with containers in mind. And you saw this, I think, really makes sense. The biggest advantage of Quarkus is this build time optimization. So it's really this optimization for the win, because that is the reason why we can go native if we want to. That is the reason why it really starts up fast, why we have great response, resource consumption savings, and it's just really good idea if you think about it. It also builds upon these known APIs such as Java EE, Jakarta EE, Microprofile, even Spring in some sort. So you cannot run a full Spring application there yet, but it supports some annotations and some types, which is nice. And especially that it cares about the developer experience. And this is what I showed you. This is what it really makes it a joy to code in Quarkus, and it's just fun to use. It's especially interesting if you have an existing investment, quote unquote, in EE, which could be that you have a project there that you might think about migrating, which definitely works. So I've done this a few times with real world projects, especially if you're using modern EE APIs, and then you have to make not too many changes from my experience. And also if you have knowledge investment, right? So if you have a team that just knows about EE APIs, then it's not that big of a stretch to use Quarkus. You can use this build time optimization to go native, but you don't have to. So I showed you some comparison or some inspiration why it may not make sense for your project. And if you want to get started, go to the Quarkus websites or Quarkus guides. They are really your friend. So they're really developer focused, written with a lot of code. You can check them out just on quarkus.io. That's the website. And then just see some stuff. That being said, thanks a lot for your attention. I hope this was helpful. If you would like to find out more, you can check out all the code examples. If you follow the first link or just in general, go to my website or follow me on Twitter. I'm posting a lot of stuff on Enterprise Java in general, a lot of videos and all that stuff. Would be cool if you would just say hi or reach out. And I hope it was helpful. I hope it was interesting to watch. And if you didn't know about Quarkus up front, I hope you learned something new. So yes, thanks a lot for your attention.
Thank you, Sebastian. It's really helpful for me because I'm just on the Spring developer.
Perfect.
So it's really excited. it's really live coding for me. It's really great, and it's yeah. So we have only 2 minutes for questions. Sorry, we have some limited timeline. So we have the most popular question from the Konstantin. Can I have the same quick after build with Gradle?
That's a good question because I'm nowadays almost never using Gradle. I know there is a Gradle plugin, and it should work at least for the usual things, because the most interesting thing that you would like to use besides the usual build is the development mode. And since this has been out there for quite a while, because I know in the very beginning when it was starting up, I think we only had the Maven plugin, but now it should work. I cannot say this for 100% sure, but I definitely know there's a Gradle plugin, and this should just work as for the development mode, because that's what you care about. I mean, for usual applications, the rest is not that interesting, is actually, or I would say should not be interesting, because why would you have a very fancy build, right? But with that, yes.
Yeah,
but then it's also
great.
actually, if I think about it in general, the question whether you would care a lot about Gradle if you have all these development mode features, right? Because then usually you start up your plugin, right, like your Maven plugin once, and then you keep it running, and then you don't have to have the incremental compilation or something like that, because it will be done by Quarkus. So I would say it's probably with Quarkus, it's not that much of an issue. But if you want to use Gradle, yes, then you can check out if that works as well.
Yeah, great. Thank you. So sorry, but we have limited timeline. So I think we need to end our Q&A session. Thank you very much, Sebastian. And I think we can proceed with the
Thanks
next
for having me.
speakers. Yeah, thank you. Have a good night.
Thank you.